2 more minutes. When it reach 150, I will go. Okay. Okay, I will announce after all of the team will all of the student will come in. Okay, maybe after the break, I will have an announcement about the next week test. Okay, 46. $47. One more. Okay, so let us go. Yeah, so today we start the lecture with the secure software design, right? So it will serve you, for the last section in your deliverables. Okay, I know that all of you already finished. Most of you already finished this section in the deliverable 1. Okay, section number 9. All right. I do have a meeting with all of you, some of you through physical meeting and virtual meeting outside of the lab hour, and also answering all your questions with the emails. Right. So on one hand, I am very happy that you work very hard and diligent on the deliverables, right? But on the other hand, it's adding up a lot of require a lot of effort from myself and Raymond as well, because within the 2 days of the weekend, we received so many emails from you guys clarifying the question related to the deliverables. But anyway, it's good. Okay. Yeah. So okay, security designs somehow, you have so many features, and then whether it's it could be you have so many features, and then you open up a lot of attack surface, right? And how do you design those features usable but also satisfying the security requirement is really a challenging task, right? So for example, this is one of the issue with WhatsApp, right? So WhatsApp allow the user to delete the message when we send a message to a group, or we send a message to somebody else, and then like a wrong chat room or wrong person, right? So wrong destination, we want to delete. But the problem is that if you send a you send a picture, right, or attachment, right? Then when you delete, it doesn't delete, because some of the user, they allow the attachment or the image is directly save into the folder, right, storage folder, into the media files, right? And when you delete that, those messages and those attachment or image are not deleted, right? So whether this is a features or is a bugs, right? So you have to consider, right? Okay. Right. So the design here is going to be important. in the case that especially for the security aspects, right? So we will go through a few principles, right? Especially the design principles related to CIA and AAA, right? So we follow the OWASP principle, security principle, okay, and design security design best practices, okay. But before that, we will have some kind of general process of the software design. Of course, you already most of you learn about a software design in 2201, right? Okay. We add some more in this lecture on the security on the design of the security controls, okay. Right, so in terms of the design principle, we also talk we will talk about a security architecture, secure software design, and the secure agile development. All right. As usual, if you have some question, you can put on the Slido with the QR code is there, number is there. All right. Okay, general process of the software design, right? So as I mentioned, you all learn about general process in 2201, right? So how first one, we look into the architectural view, right? So you draw some architecture, the component, logical components, and then the architecture patterns, right? And after that, so first we will have very abstract level at very high level design, okay, of the software, and then we go into the details, right? So when we look into the details, we will have to look at the interface design and then the internal of the component design, right? And also we design the pattern, right? Okay, and finally we go into every component, right? When we go deep, right, this component go here, then what is the flow, what is the data flow, or how the data is processed in that component, right? From the input, how to process the input to get out the output or the outcomes, right? Okay, a lot of application will use database, right? So we also have to based on the table, database table, right? So we can have, in terms of construction, we can base on a data flow or we can base on a table, okay, right? Okay, so the details design here, detailed design is to provide a white box design elements, right? So white box means that everything is open, okay, and everybody can look into the component and see what is the data flow, what is the instruction, okay, and we will see that we know about the input, we know about the output and the expected output, and we know how the component is behave given such a certain input, right? Okay, right. So in terms of the interface design, component design, I already discussed with you. All right. Okay, so the interface is really, you know, due with the specification, right? Because component will communicate with each other, right? Will have the interaction with each other, right? So you should have the interface or the functions in each of the component to allow the other component to invoke, right? Okay. So recap, right? So this one is what, as I mentioned, we learn about the 2201, okay? So we can design in terms of the architecture, the software design, we can base on the block and line diagram, right? So this one is a block, right? We have the data source, and then after that, using the arrows, we will see the data flow, right? Coming from one component to another component, okay? And finally is a data sync, right? So you see here the component will be the filter 1, filter 2, etc. Okay. You can also using this kind of, you know, like this component diagram, right? So this is component diagram is you know, like very famous when you use a UML, right? Okay. I believe that the project from Prof Alex is request you to draw all of this figure correctly and properly, right? Okay. So the internal, right, the interface design here, because you see, like for example, in your web application, you have multiple user type, right? And all of them, they may have the same function, same functionality, for example, same feature, for example, updating the personal information, personal particulars, right? However, each of the user, because based on the user role, you may have a different details inside the form, the update personal particular updates, right? So that's why we can build up this interface, right? Okay. Right. So the interface here allowed and all, right? So allow every component having a different or details implementation. Okay. All right. Or maybe the order as well, right? So the customer may have the order, right? Okay, the order here, and the order. So the interface here is actually the place order, allow different customer, different user to place order, but implementing this play order is been depends on different products, for example, right? Okay, so this is the interface design where we have one class and then having a few interfaces. All right, and then after that we go here, we go down this one with the details level of the interface, where we have a parameter of the interface of the methods, right? Okay. All right, and then if you want to model the internal behavior of the component, right? Then you can have this kind of interaction, right? From actor, and then you connect to this student page or student info page, right? And then with the action here, the feature here, printing, okay. And then go to the next one is transcript builder, for example, right? Because the user would like to print out the transcript, right, request, or to export the transcript in the PDF form, for example. Okay. All right, so that they would have this kind of function here. Or maybe the student would like to get the list of seminar is ongoing, right, to to attend, right? So that's why they can have this. So, and then once you have the seminar, then the student can go to the get a mark or calculate a mark, whatever, right? So you see, this is kind of the internal behavior design, okay, of every component. Okay. Right, so that is other request from the 2201. Okay. Now when we had this question in the past, right? I think on week 2 we discussed about the flow and the bugs, right? Okay, so when we want to make the software secure, right? We have to consider the security design as security aspect during design. Okay. And if we do not take into the security right at the beginning, okay, you may have a lot of flaws, right? You ignore the security at first, you view and design your software, and then satisfy all of the functional requirement, and at the end you put in a security, then you may have a lot of security flaws there. And the problem is that flaw you cannot fix, right? Okay, bug you can fix, okay, but the flaw you have to do a regression back to the design again, right? So that will include a lot of incurs a lot of the effort and additional effort, okay, and will delay the release of the software. Okay, so so the best approach is that start the security mindset from the start, okay, from the beginning, and then bring into the security analyst and security engineer to consider all kind of security aspect during the design phase. All right. Yeah, so this one I just mentioned about bugs and flow, right? As I mentioned, flow are a problem in the design, and the bugs are the problems in the implementation, right? So we make with a very perfect design, we still may have a bugs. Okay, we still may have a bug because the bug is generated by the, you know, like a careless mistake of the programmer, of the developer. Okay, right. We should avoid the flow during the design phase. Okay, and the study is showing that, you know, 50% of the security problem is coming from the flows, right? And as I mentioned, flow cannot bug. You need to do regression and do the designs again. Okay, right? So the security principle, right? So we follow the OWASP security principle. Okay, there are a lot, right? But I put here the top 10 principle that help you to write a secure code to implement your web, you know, your application secure and safe, right? So those are the things here, right? So the top 10 principle is minimize the attack surface, establish the security default, right? Principle list of the privilege, principle of the defense in depth, etc. Okay, so we will go through these 10 best practices. Okay, these 10 design principle in the next few slides. Right, how to minimize attack surface area, right? As I mentioned with all of you, that as long as you add in one feature, you will open up or you will add up some more you know some more risks, right? Some more attack surfaces. Okay, right. So we need to aim, all right, aim to reduce the overall risk by reducing the attack surface. Okay, so the problem here is that if you want to reduce attack surface, why having the same features, right? Of course, if you don't want to, you know, you don't want to have any attack surface, that means you don't have any feature, right? Then your app will be, your application will not have any attack surface, right? But it doesn't make sense if an application doesn't have any feature, right? So the challenging question here is that how do we still have the features, but we can reduce attack surface, right? So that means we need to find a solution to satisfy the requirement, the functional requirement, while minimizing the attack surface. Okay, right? So a lot of the risks and a lot of attack can happen, right? So you see on the right side here, okay, is a statistic of all kind of attacks. It can happen to your application, right? And you see a lot of attacks you can minimize, you can avoid during the design and implementation, right? Okay, the biggest one is denial of service, right? 17.12% is quite, this one will be the kind of external attack, right? And you can protect your web application with WAF, right? Or maybe with some firewall, network firewall, right? So this one is not, maybe it's not relevant to your implementation and security design of your app much, right? Because anyway, we need to use third party, for example, Cisco firewall or WAF or whatever, right, to protect your VM, to protect your web app, right? So, but it's not internal, the implementation of the application. However, remaining attacks you can avoid by implementation and security design internally of your application. For example, SQL injection is the second biggest, right? Is the second biggest attack. Okay, it's occupy 15.77%, right? So, and it's coming from where? It's coming from your the forms of your, where the user provide input, right? Okay, so we should reduce this attack surface, right? So for example, instead of text box, can we change a text box by a combo box, a selection, right? So the user, instead of type in a sentence or type in a phrase, they will choose the available option. Of course, it's maybe less intuitive, and it's not really flexible compared to a text box, right? For example, the searching feature, right? But at least you still can satisfy the requirement. Okay, so all of this one are the attacks. Okay, and it lead to some risk, right? For example, SQL or injection attack in general can lead to the information disclosure or data leakage. Okay, so it's right. So we try to minimize all of this, right? Okay, so here is example. Just now I mentioned about a searching, right, or the help online. Okay, so a lot of web application allow the user to have an online help, right? With a search function here. Okay, so when the search function, if you will have some kind of text box, type in the sentence, this will face the SQL injection attack, right? Okay, right. So you see a different level of the threat, the attack surface here, right? Let's say if search function is open to the whole internet for all kind of user, you will face a lot of every user, every attacker, right, all over the world, right? But if you limit this help feature to only the authorized, that means the user have to log into the application before can use the feature, then you reduce attack surface already, right? Because you reduce the set of attacker to only authorized user, right? And then after that, this feature search function was gated through a centralized data validation routines, right? So that means you do some input validation, sanitization, whatever, right? So then it's reduced further, right? Reduce furthermore the attacks surface. We still allow the user to type in, right? Okay, but if you do the validation, at least you still can reduce a little bit more. Okay, and if you can rewrite this search function instead of type in, as I mentioned, you allow some a list on of the possible phrase, right? So you see some web application, they will put in the combo box, okay, like asking the user, okay, what is your topic of the question, right, in the list of the possible option in the combo box. Then the user will only click, right? Okay, so this like that we can reduce a little bit more the attack surface. All right, okay, so you can have more information about attack surface analysis with the OWASP, the design principle here. Okay, so related to this attack surface analysis, if you go on the OWASP website, you will see a separate folder for this, right? Okay, related to attack surface analysis. Yes, so you can go there, you read, and then you can find more information. Okay, so we focus on this one here. Okay, so the attack surface analysis is usually done by the security architect and pen tester, right? So, okay, in your project, I as student have to stand up and check the list for this, right? Looking through your web application, see where are the possible attack surface. Okay. Of course, software engineering student can comment and provide a feedback, right? Okay, and especially important is that and identify what function and what part of the system we need to review and test for the security. Okay, right after that, but it could be so many, like attack surface in the application, right? So we should mapping and identify those attack surface into different categories, and then from there we can provide the mitigation techniques, right? So for example, one of the thing here very common is a user interface forms and a few where the user provide input, right? Because this one is related to the SQL injection. Then this one as well, HTTP header and cookies, right? Because some of the parameter you may pass through the HTTP header, and then the cookie is also, you know, linked with the HTTP header, right? So these are the things that you may have to consider. All right, and then the API, right? The API and third-party components, because you use a third-party component, you rely on the security of the third-party components, right? Okay, and they are in a different trust boundary with our web application, right? We don't know Google, you know, CAPTCHA, where it stay, right? And how is this regulation or the policy in that place, right? And actually we are in a different trust boundary, so we have to, you know, analyze that one. Okay, analyze those, so to make sure that it is secure, and if anything is suspicious, then you have to look in and find a solution. Okay, files, because some of your application allow the user to upload image, upload file, upload CSV file, upload attachment, right? It could be malicious code inside, right? Okay, database as well. Okay, other local storage. Okay, right? Email or other kind of message. Email, of course, because you may have the attachment, right? And the attachment is could be back to the files as well. Okay. All right, runtime agreement. Okay, runtime agreement. Sometimes, for example, if your SQL injection, right? Even you get it from here and there, but your user can change, right? When it sniff the HTTP header or sniff the traffic, right? These are the input. Okay, and then and you see that when you use Microsoft Stride, right, it's list of, you know, a huge number of threads and showing a lot of attack surface, entry point, exit point, right? So that's why, again, for this you may have a different way to categorize and classify, right? So for example, you can classify, categorize all of attack surface related to the login authentication entry point, or related to the admin interface, or related to the inquiries or search function. All right. Okay. Transactional interface or API. Okay, so all of these one are the place where the, you know, the attack surface can happen. Okay, can be present. All right. Okay, so that is the identify and mapping attack surface analysis, right? So the next principle is establish SKU defaults, right? Of course, you may have so many, you know, like creative, innovative solution, you know, to bring, you know, the flexibility and the usability, friendly GUI to the user, right? A good experience to the user. However, whatever the, you know, the user can do, and the user action have to be done in a perform in a securely in a secure manner, right? Okay, so and then it should be up to the user to reduce the security if they are allowed. All right. Okay, so some of your class, some of group asking me whether we should allow user to upgrade the security or downgrade security, right? So like setting default is like one of the team asking me whether I should put default for the OTP is without the checking OTP, right? And then allow the user to add up, you know, enable, right? So that we should not do that, because by default we should have the best security, right? But as I mentioned, because very complex security will lead to a you know, the user unfriendly, right? So in that case, then we allow the user opt in to choose to reduce security. So that means by default we have OTP, and then if user face thing that is very complex and it's not important for me, then they can choose to downgrade by saying, okay, I don't want to use OTP, right? So like that is okay. Okay, and right. So for example here, like by default, password aging and complexity should be enabled, right? But if the user say, I don't want to change my password every 3 months or 6 months, then it can click, you know, disable this feature and say that, okay, I accept the risk, and then I want to use the sole password for the whole life. Okay, of course, it's when you disable the security aspect feature, right? Of course, you will pay for the cost of increase in the risk. Okay. Establish the security default, right? So for example, here are some of the example of the established security default. By default, HTTPS have to be in place. Okay. On of the logging attempts notification have to be right. On of the logging attempts have to be notified. Okay. Any information chain have to be notified. Okay. Or maybe when you have a register, when you register a user, the first time he log into the web app, first thing they need to do is changing the password, right? So those are the security default that we may think for your web application. All right. Third one, principle of the least privilege, right? Again, come into when you log into the application, especially for those application with your project having multiple role of user, right? So this is important. Any user once log in having the least privilege first. Okay. And after that, let's say if I am an admin, first I log in, I will log in as a user, normal user, right? And then after that, inside the web app, I will, you know, escalate, because that is my permission, right? Because I have another user role, right? Then I escalate to admin user. All right. Okay. So so because every user role like encompass, you know, with the user right, resource permission, whatever here, right? So come in first should be the normal user before they can upgrade, right? Okay, so this is one example of the principle of the least privilege. Okay, so by default, a middleware server only require access to the network, you know, just for reading access to the database, and read access to the database and write to a log. That's all. Okay, so this is will be a default or normal user role, right? So in that case, the middleware doesn't need to be, you know, to be at the admin level, right? Admin privilege to perform on this kind of action. Okay, right? So these are a few other, you know, example question for you to think and then like design for your application. Okay, of course, I don't know, like maybe most 3/4 of your project will have the admin account, right? So when you have an admin account, you have to identify what can the admin account can do with the system. Okay, and then the second question is that do you allow the admin to log in or access normal user information, right? And what is the use of administrator as admin account, right? This is, I think, is the most important here. Okay. Why do you need an admin account? What is the use of admin account? Okay, how it will be used? So once you answer this question within your team, then you can go for the design part. Okay, so whether we should limit the admin account, the power of admin account or not. So you need to think with your application. Okay. All right. So here is another question. The software engineer should he has all permission to access the DB? For example, also including the delete DB. All right. Should it have or not? Okay, think about that. DB admin, right? Same question. Can he have all of information that related to the user? Right? Of course, should not, right? Because admin should not see the user personal information, right? Okay. Right. This one is the fourth one. Okay. Principle of defense in depth, right? Right. So you see here, whatever just now I mentioned about all of the attack surface and all of the attacks that you can protect within your implementation, right? However, for some of the attack you cannot, for example, DDoS, you have to propose and to deploy the solution to protect your web application outside of your web application, right? Okay, so that's why we have the defense in depth. Okay, we have the defense in depth, right? So in generally, whether the application run or not run, okay, you should have the first level of protection is a policy, procedure, and awareness, right? It's kind of regulation. Okay, the rules from the government, right? So this one again, right? So the human can break that one, right? And then if the human breaks this one, it will go into the feed system, right? And perform the attack, right? So then you will have the physical protection, right? Okay, physical protection, for example, you know, like you put on of the hard drive in a proper, you know, data center with a lock, for example. Those are the lock. Or maybe my server is keeping in my house, in my study room, right? And with a door lock. Okay, right? And then after that, you have the perimeter. This perimeter actually the firewall putting at the trust boundary. Okay, at the trust boundary, right? Mostly the one perimeter for the entire company, right? Okay, entire organization. And but with that you know, the perimeter is cannot protect, you know, cannot applicable for a particular traffic or particular application, right? That's why you go down to the network level. Okay, to the network level, right? So where you will have different subnet, different security policy, right? Then that's why you will have one network at the network level proxy and for protection, right? And then after that, you can from network you can go down to the host level, right? Okay, and finally will be the application level and the data level at the end. Okay, so so this one is just make it clear of what we saw in this slide, right? In terms of policy aware, how we deploy our security control into this area here. We will see here, right? For example, a user with the application, right, for web browser, then it can perform a few security aspects. For example, SQL as client certificate, right? Maybe a secure cookie, local storage, all right? Or maybe doing the encryption, encoding, and hash input validation, whatever here, right? At the server level, then you can have the DDoS. You bring in the secure controls that protect against the network attack, right? Okay, so at the proxy and CDN level, okay, so we can bring together the IPsec, IP security, WAF, SSL, array limit, whatever here, okay, to control, to protect the sample, to protect the application. All right, and then after that you may have firewall, right? Also at this level you also have the firewall, right? And you have a load balancer here to provide the availability, right? And provide the schedule, the load balancing. Okay, once you have go down to the application level, right? You will have privilege, input validation, SQL, injection, elimination. Okay, right? And then finally, the next is will be the authentication within your application implementation, right? You will have authentication, authorization, encoding, encryption, etc. And finally, this one is a is a storage level. Okay. All right. So the next one will be failure, right? Of course, you will not have a software that is 100% perfect and will never have any failure or will never have any exception, right? Okay. However, so that means we accept the error, we accept the failure, right? But how those failure happen securely? Okay, how do we handle those errors securely? And without error, even with the error, the attacker, right, will not gain so much information. Okay, right? So for example, just now, like I had meeting with one of the group, right, asking about the logging, right? So logging, a user can put in the wrong username and password, right? Even though they don't know, right? But just like trying luck, right? If they can get it, then they can compromise your web application, right? But when you put in it with two fields, right? The username and login, and surely the first attempt, the attacker cannot be successful at the first, right? So they will try multiple ones. So for the first one wrong, how do you show the message to the user? Whether you say that, okay, your password is not correct, or your username is not correct. Okay, should we say like that, or we say it's more general, right? Okay, for example, your username or password is not correct. Okay, so how we do all of this is will be the principle in the handling error, right? Right. So one, but you also have exception as well, because that is the error happened due to the user providing a wrong input, right? But maybe during the coding, during the runtime, right, you may face some kind of exception. It's really rare happen to your web application, right? And how do we handle that, right? Okay, so as a developer, you should consider and there are general three principal outcome for the security mechanism, right? For example, here we have allow operation, disallow the operation, or exception. Okay, so here is one of the example. Okay, so this one, right? Because you know about Java, right? So this one is actually a Java code. Okay, so Java code, the main code is actually these two lines. Okay, and it will be encompassed in one of the trackers, right? So tracker means that if something have wrong or something happen with the code with malware, or it can happen with this function, right? It may throw out some kind of message, right? So you see what is the problem here. Okay, The problem is that because we have this assignment, right? Is admin equal to true. So whatever here and listen, if this one of this throw an exception, then it will come here, right? And it will try a log. Okay, but and then here, what is the value of is admin? It's already equal to true, right? Okay, because we have this assignment. Okay, so some of the coders think that, okay, we make assignment in any way, we change the values of this admin with this function, but they never know that this function can be throw an exception or can be crushed, right? So how to fix this one? I leave it for you. Okay, the next principle is that you do not trust any service. As I mentioned in the first lecture, we try to build a zero trust infrastructure, right? So you should not trust any third-party software, okay, or maybe cloud, right? The problem is that you don't have the overview control or the influence on the security aspect of those you know, third party. Okay, right? So therefore, we should not implicitly trust, right? Okay, so in this case, it's the best to consider all of these third party having the least security, and we verify, we see that, okay, whether it satisfies the security or not. First, we have to assume that all of these third party having the lowest security you know, aspect. Okay, right? And then after that, we make the assumption that we don't trust. Then we find like what are the security solution to address all of this. All right, okay. Even though, you know, like we already discussed with so many, you know, so many giant, right, scenarios of the giant company having the issue, right? So you see, for example, Cloudflare also have, you know, third party also have some bug, right? AWS have some bug, okay? WhatsApp also have some bugs. So those are the big companies. So you don't think that if they are big company, then your software will not have any issue. That is a wrong assumption. Okay, that's why we should not trust any third party, whether the owner of the service is the you know, the company, the owner of the service is really a big or really famous or reputational or not. Okay, of course Google is really a big company, right? But Google implement software engineering may have so many level, right? Some may be very senior, some may be just junior, like you just graduate, right? So they may make a mistake. Okay, we don't blame on a mistake because we learn from a mistake, right? But we have to prepare for the worst. All right. Okay, next one is separation of the duty. Okay, right. So this is also a good principle of design, right? Right. So for example, here someone, you know, requests for a computer should not also sign to receive, right? Because this one, okay, this one may lead to problem of repudiation, right? So let's say that if like one guy requests and the other guy is receive the books or receive the good, then they can, you know, cross-checking, right? Make sure everything is come to the having a clear, okay, having a clear logs and can satisfy the repudiation requirements. All right. Okay, so here is is a sample of the separation of the duties. Okay, administrator should be able to turn a system on and off, right, and set a password policy, right? But it shouldn't be, you know, logged onto the storefront as a sub-privileged user to perform the purchase on behalf of other user. Okay, right? Okay, avoid security by ops security. This one is a lot of people mentioned with me in the labs, right? We're not saying that ops security through ops security is, you know, it's not a good point, right? Okay, a lot of companies still use security through ops security in their implementation, right? But we have to confirm that security through or security by ops security should not be the only one. Okay, should not be the sole security control, because security, this one is a weak security control, right? So of course you can use security by ops security on top or, you know, in addition with other security controls. Okay, but only one of each is not right. Okay, for example, a lot of you say, maybe saying that, okay, I developed the code and then I release to the customer and client the compiled version, you know, the binary only, right? So whatever I put into my code, the user, you know, client may not know, right? Or client may not have the knowledge to know and to look into that, right? That is a weak assumption, because maybe client have some technical knowledge or having some kind of reverse engineering tools, right? Okay, so, or the compiler, right? Then it can look back to your code, right? Okay, so that's why hiding something in the code is not a good way to do. Okay, right? The security, so because of that, security should rely upon many other factors, right? For example, password policy, defense in depth, right? Defense in depth we already discussed in the first few slides there. Okay, business transaction limits, for example, solid network architecture, and the fraud and audit control, right? Okay, the very famous example here, right, is a Linux one, right? So I know a lot of you using Linux, right? Ubuntu, right? Very famous Linux-based OS. Actually, the source code is open, right? It's open to everybody. You can download the source code, right? However, it's very secure OS, right? You see a lot of attack happen with Windows, but it's very less attack happen with Linux, right? Of course, there will be some attack there, right? But it's much lesser, right? Okay. Okay, so the next one is keep security simple, right? Okay, we come back to the password policy, right? We design our application with very complex password policy, and then we end up with another stress, right? Because we have very complex password policy, and user have to, you know, it's very hard to remember the password and have to write out somewhere else, right? So it's finally leak it. Okay, and the problem is that when you have very complex security, it's not only the password design, right? But in terms of, for example, authentication, or you know, for example, if you have authentication with a 2FA or OTP, or you may have another additional step, right? But because you don't implement all of that, you have to use additional third-party solution, right? And you see, when you have all of that, you open up with different trust boundary, right? Okay, and you don't have to control all of this third party. Okay, so you end up, maybe you open up with more attack surface and you open up with more vulnerabilities, right? Okay, so should keep it simple, right? For example, avoid to use double negative and complex architecture. All right, and of course, when you have very complex mechanism and multiple steps, right, the overhead here is the efficiency is when we decrease, right, because it will take so many times, so long time for a user to achieve some outcome, right? Okay. All right, so this one is one example of the keep the security simple, right? Okay, fix security. The next one will be the fix security issue correctly. Okay, because you know, like whenever you have a security issue, right, you will propose, you will develop some feedback, right? Okay, but of course, combined with that, along with the fix, you also should develop a test, okay, to make sure that the issue is not happen again, or we don't open another one, right? Because when you add up some more additional implementation, right, you may have some other bugs, right? That's why testing the fix is a must, okay, and to understand the root cause of the issue. All right, okay. And there's one more thing related to this, right? Because nowadays a lot of software, you know, like we bring in the design pattern approach for development of the software, right? So whenever you have one issue, right, it may present in other components in the own code base as well, right? Doing this, developing the fix here, have to check throughout, you know, thoroughly for the own code base to make sure that, okay, we don't miss out any place. Okay. Right, here is another example, right? So you can think of the solution. So a user has found that, you know, they can see another user balance by adjusting the cookie, right? Okay, so the thing is that, right, so the fix here is just quite simple, right? Make sure that the cookie is only have to be unique, and it's really very hard to guess by changing, right? For example, make sure that if the user change a cookie, it will not phone to another cookie, right? It's not be matched to another cookie, right? So make sure that the cookie is a bit more complex. Okay. But however, because this cookie is used for many pages in your web application, right? All right, and it's not only linked to this like balance viewing, right? It could link to other problems as well, right? So once you test with that, you fix this one, you may have to fix and to test to other functionality, right, where they use the cookie. Okay. Okay, right. Security architecture, we go and a bit you know, a few more minutes and then we have a break. Right, a security architecture is really important, right? So here is you know, like a claim, right? The application without security architecture is like a bridge constructed without a finite element analysis, right? So you see on the right is the London Bridge is falling down. Okay, Okay, so you need to design the application security in the form of the security architecture, right? You have to look into every bit as great as the building of the bridge construction, right? So in security architecture, you have both, right? As we require you, require you in the deliverable one, right? You need to have the physical architectures where you have different physical component, okay, locating a different, trust boundary. And then after that, you also have the logical component as well, right? Also, those logical, it's a software component, a logical architecture with multiple software components. They also locate in different trust boundary, right? Okay, because some of you have a third party, right? I saw that one of the team sending me an email about a cloud Dictionary, right? So that's why I asked the question, where is this the cloud Dictionary is installed, deployed in the DigitalOcean, or it will be located in another location, right? Because if it's, let's say that cloud Dictionary is located in like Google Cloud, right? It can be in another physical location. It has to be included in the physical infrastructure, physical architecture, right? So of course it has to be in the logical, architecture for sure, because that is one of the software component, right? Different with your with your component you develop in the application, right? But if it's in the same, deploy in the same virtual machine with the DigitalOcean, then it will be part of the virtual machine, right? Okay, but if it's out there in the Google Cloud, then it have to be present in the physical location, physical architecture. Okay. Especially as is similar for other, other question you really related to kind of, CAPTCHA, other, OTP messaging or payment gateway, right? So all of this, when you bring into your application, you have to consider, right? So these are the related to the security architecture, right? So when we design that, it's not only for the attacks, okay, but it's also related to this one as well, especially for the food traffic, or like for a disaster, right? Because all of this one can be related to the availability, right? Okay, so the physical architecture has been linked to this way as well, right? Okay, so application designer must cope with the extreme event, right? For example, brute force attacks, or fraud. Okay, so you need to bring in all of this one. Okay, so the security architecture, right? Because when we're talking about a functional security requirement, we're talking about confidentiality, integrity, okay, availability, right? And then the other 3A, right? Authentication, authorization, okay, and accountability, right? So the security architecture, you need to refer to those fundamental pillars, okay, right? And of course, security architecture is not a combination of multiple security control or multiple components, right? It's not like your place, a dish, and then you put whatever you want on your dish, right? It should be, they have to work with each other, they have to collaborate, because you already talked, we already discussed about the defense in depth, right? So at every layer, we have some of the components, some of security control to take the responsibility for protecting our web application. Okay, So there will be no duplicate of work, okay, and there will be no overlapping, right? For US requirement, you will have all of this, right? So it's clean carrier, clean apps, clean store, you know, clean cloud cable or the part. Okay. Okay, so maybe we stop here for a while, and then we come back with some announcement. Let's say we have 5-7. We have maybe 5-minute break. Okay, so a lot of quicks mentioned here. Okay, I will come back with the next announcement, and then I will answer all of these questions related to the quicks. All right.
Recording stopped.
Okay, I'm back. Right. We continue the recording.
Recording in progress.
Okay, next, how many students are there? Okay, 183. Yeah, so actually it's only 3/4, right? Around there. Okay, important announcement. Quiz. All right.
Quiz.
Okay, so the quiz next week will be right. So next Wednesday. Time is 4:05 to 5:05.
During
Right.
lecture.
Yeah. So we will have next week. We still have 2 hours, right? 2 hour lecture. I will spend 1 hour for the quiz, and then the remaining hour will cover some part of the lectures. Okay, to finish my first half. All right. Okay. Why starting from 4:05? Because I want you to log in by 4 and preparing your environment. Okay, your environment. Because you have to log in your XI. You log in the logout. Use turn on the logout browser. Doing on the check environment, whatever. Right. Okay. And then from 4:05 you will start on the I will make the quiz on the LMS is available. Okay, and then you will do it, start it. Okay, we finish at 5:05, but why we continue the lecture at 5:20? Because in our class there are 2 students need additional time. Okay, so those will have additional 15 minutes. That's why those guys don't need, then you have a longer break, 15 minutes. Okay, scope of the quiz will be lecture 1 to lecture 5, so make until the end of the lecture today. All right. Okay, until the end of the lecture today. Right. How many percent of for the quiz? I don't remember. I think it's 20%. Could you please look back to the first set of slide of the week 1? But I believe it's the 20%. Okay. All right. So that is on the information related to the quiz, right? Then let me answer some of the question on the XI, on the Slido as well in the chat, right? Okay, Ryan, how many questions? The number of questions is going to be suitable for you within 1 hour. I believe that if you already learn all of this, you know all of this, within 30 minutes you will have you will finish. Okay. There will be maybe a few questions, very small question. You need to type in the answer, kind of an open-ended question, but it's very small. Mostly is MCQ, right? Okay. But of course, if you make it, then think like 30 to 45 minutes, you will finish. It's just only MCQ, right? You look at the question, it's already like 1 minute later, you already finish. Okay. And it will not be a 60 question, right? Much less than that. All right. Okay, too much content to absorb. Is a 2-hour lecture, 12 weeks. So those are the contents we already summarized a lot. Okay. And I think those other content is very important for you to take note. We don't bring in any other additional content. You know, software engineering is a long time established domain, right? It's like a networking. Okay, so don't complain about the content. Okay, the more you learn, you know more, right? It's like you read more book is better. No, lab resources will not be tested in the quiz. Lab resources will be tested in the practical test. Okay. Right. So we separate the duty of every component. Okay. What is the format of the quiz and how many questions? How long is this? Okay. A lot of I already respond, right? MCQ. Like 80% of the question are MCQ, only 10 to 20% are the open question. And then 1 hour, some of them, two of you having additional 10 minutes. Okay, security design is only covered this week, but 20% of report is due in 2 days. Extension for deliverable 1. Okay. I should make one thing. Okay, so let me do one thing. I will make a vote. Okay, for the extension. All right, I will make a vote, and then you vote for that. If all of you agree for extension, then we will extend a bit. Okay, so this one I keep it here. Quick is online. Yes, you stay at back home. You find a corner where you feel very comfortable. You open your laptop, turn on the Xi, log in Xi, and turn on the lockdown browser. You should know lockdown browser, right? Okay. And if you don't know lockdown browser, go on the quiz in the Xi. For this module, we have one test quiz over there. You can try. Okay. If you don't know about lockdown browser, so go to LMS. This module ICT 3x03, go to assessment tab, and then quiz, you will have one there for testing. Okay, what is the difference between logical and physical security architecture, right? Okay, so physical architectures is actually you will have the component, the physical component. For example, web application, it will start with the client web browser, right? So surely I will have one. I will have one component as a web browser, right? And then the next physical component will be your DigitalOcean, right? DigitalOcean, okay. And if you have a third party, for example, you know, cloud dictionary in Amazon, Amazon or Google Cloud, right? Or you may have CAPTCHA from Google Cloud, right? Then that one will be another physical component in your physical architecture, right? Okay, maybe if you put, let's say that your web front, you know, web front end is actually in the DigitalOcean, right? And the database schema and database storage, right? You know, SQL database you have in the Amazon S3, for example, or in Amazon EC2, then you also have another physical component, right? Okay, or maybe some of you using the Amazon S3 to store the image or, you know, file, right? Then you will have another physical component there, right? So physical here is meaning that you will have a trust boundary between physical location, even though we don't know where are they, right? But we are sure that they are in different physical location. Then you have to separate in the physical architecture. All right. Logical, of course, bring in the physical first, and for every component in the physical, you have to separate into multiple software components. For example, let's say just now we mentioned about the web application in the DigitalOcean, right? So in DigitalOcean VM, you deploy additional WAF, right? So that one is one logical component. Okay, you will have front end, you will have back end. Okay, right? And then if the database is not in some other place, it's not in some other physical place, the database is also in DigitalOcean, then in the DigitalOcean VM, you have 3 components, right? Okay, so hope that clarify what is the difference between logical and physical security architecture, and then also this question. Any hints and tips for the quiz? Please look back to on the revised lecture note for from week 1 to week 5. Yeah, that is my tip. Yes, the quiz is cover lecture material only. Okay. Of course, when you have the open question writing, right? You have to bring in the it's going to be the theory, what you understand about secure software development. Okay, we don't bring in any practical coding whatever here yet. We will not ask you to develop and program. It's not. We already test you development and implementation of programming in the project. Okay, or maybe a part of the practical test in the end of the module, right? This one online, we don't have coding. It's a lab quick. It's an online quiz. Okay, as I mentioned. No, I don't get the question here. We only have two physical, two type of architecture, right? Physical architecture and and logical architecture. That's all. MCQ can be multi-choice, can be single choice. Okay. Some question will be multi-choice. Multi-choices. Some question is single choices. Of course, we will make sure that in the question is clear, right? If the question is multi-choices, we will put in the question, please choose on applies. Okay. If it's single, then we don't say anything, or it will be like, separate by the tick box, the tick box or the option, right? It will be the square or the circle. You can see that there. Okay. You should know all of this in the Blockdown browser, and I don't remember, sorry. There is one question about how many multi-choice, how many multi-selects. What is the difference between multi-choice and multi-select? You have the same amount of mark for each question. Okay. All right. Okay. So this one. Okay. The quiz and the lab practical test. Please look, the percentage. Look back to the first question. I don't answer this one. Okay, multi-choice, not multi-select, right? Okay, I don't know. I don't understand why you mentioned this. A multi-choice question is a multi-choice question, right? Why is not multi-select? All right. Okay. Yes, I go down to this one. Do we get practical partial mark if we select certain correct? Yeah, of course. Of course, you will get partial mark. That is a point of multi-choices. But you may have negative mark if you choose the wrong one. How to study for the quiz? Look back on lecture notes of lecture 1 to lecture 5. Deliverable in section 9 feels similar to an early section Yes, yeah. So the design, right? So but it could be a bit more details compared to the threat modeling, right? Because the threat modeling, you may only see on kind of threats, right? On kind of threats happen to your web application. Okay, we can discuss on of the question related to the project during lab hour tomorrow. Okay. All right. This also please come back to me tomorrow. No, sorry, I don't have any simple quicks. You may search for the quicks on the internet. In the internet, I don't know we have or not. Do we focus on the quick? It's up to you. For me, I focus both of them because it's having a good mark, right? All right. Okay, let me make a vote for this. For the extension, right? Because you utilize some multi-choice. Okay. Good. For G1. Yes and no. Okay. Please vote it. Okay. So I got 100 response, I stop. Okay. I will consider that it's going to be a majority of the. Okay, we try to how many we have? 800, 188, right? You try to 120. Okay. Okay, stop. Then we extend. Okay, I extend the. All right, I stop this one. So I will make an announcement on AMS. Okay, for the extension. It will be until let me see, until Sunday. Okay, so you have Saturday and Sunday. All right. So I will extend until Sunday midnight. Okay, I will make an announcement on AMS until Sunday. Yes. Okay, I will make until Sunday 23 hours 59 minutes. Okay. So it's Sunday is on the 2nd of October, right? Yeah. Okay. Sunday is 2nd of October. Okay, it's going to be like our new deadline. All right. Okay, so let us continue on the lecture. Okay, because I also have to run on of this, otherwise you will complain with me that I do not cover the lectures for the quicks. Okay, security, secure software design. We have all of this part, right? We have confidentiality design. Is you see? So you see here actually. CIA and AAA, right? We will look into all of this one. You know most of them already, right? But let us go through again for those this part, like that. We have a systematic revision on the security design. Okay, confidentiality design. You know, so to protect the data privacy, right? So we have two approach. Two techniques. One is masking and one is cryptographic techniques, right? So masking, for example, for especially the password, right? So the password, when the user type in the password text form, you need to mask with the you know, the dot or with you know, or with a star, right? This to prevent the snooping, right? Because the people, you know, some of the guy, you know, standing behind us and looking at us and then seeing all of this one. Okay, so the masking is for that. Cryptographic technique is protecting the data address. So that means like storing in the cloud database, in the, you know, in our database or in a storage place, or data in transit. That means the transfer from between the web client web browser to the web front end or the backend. Okay, so this is the purpose of the two techniques. All right, we can use for the encryption, right? For the cryptographic techniques, we have two approach, two way with the two algorithms, I would say. The first one is symmetric algorithms, where we use only single key, right? So that means when we use cryptographic algorithm to encrypt a data, right? We're using a key, then we need when we want to read, we need to decrypt the data for reading, right? Back to the plain text to see the contents, right? So symmetric algorithm using the single key for encrypting and for decrypting. Okay, sharing this, you know, sharing this key between the partner. So for example, the user and partner, or, you know, user and the database should be in another methods, right? Okay, all right, so in another channel for sharing, okay, the key, right? For example, like us, right? When we we encrypt some key, right? We send some document to your friend with the draft, with a zip file, right? And then by WhatsApp or by message, right? You send a password to your friend, okay, and use that to decrypt, okay, to unzip, right? Okay, so that is symmetric. Asymmetric is we need to use a key pair, right? So this key pair is private key and public key. Okay, where private key should not be shared with anybody else. It will be held by the owner of the key pair, right? Secretly, and the public will be shared to on other partner to encrypt the information, to encrypt the data, right? And the private key is, it should be computational infeasible to derive the private key from a public key, right? Because if you send a public key somebody else and then it is used very powerful, you know, computational machine, right? And then to derive the public private key, then it's not good, right? Okay, so the comparison for between the symmetric key and asymmetric key, asymmetric algorithm is here, right? So in terms of the symmetric algorithm, the key exchange had to be outbound, right? Outbound means that you use different way, right? Different means to exchange, to transfer the password, right, to the key, right? For example, just now I mentioned about like using a password to zip a file and then sending a password with a WhatsApp, right? So that means we use a outbound secure mechanism to exchange the key. So the number of key among end user is only one, right? Because we use the same key for all of the pupil, all of the user. So because of that, it will be very efficient, much faster compared to a asymmetric key, but it cannot address the non-repudiation, right? That means because everybody using the same key, right? So if one guy using the key and doing something wrong, right, we cannot know who it is if we don't have a proper locking, right? In terms of asymmetric key, okay, key exchange we should base on the public key infrastructure, right? Okay, number of key among the n person will be n pair, right? Every person, every user will have one pair of the private key and public key. And of course, when we have more things, it will be slower, right? But it can address the non-repudiation. All right. Okay, so here is a question time. I leave this for you to think about it as a homework, okay? And when you revise your lecture note for the next weeks, you can discuss together on this one, right? So when we look about, you know, like we mentioned about a public key infrastructure, right? So right now, mostly we use this ITU X509 version 3 as you know, the public key digital certificate, right, as a standard for the public key. Okay, so you see in this X509 version 3, right, you have many other many fields, right? Version, right, algorithm identifier, serial number, CA name. You know, CA mean that the certificate authority, okay, validity periods, for example, and the name, and then the public key, algorithm identifier, and value of the public key, right? So on the right here is will be one of the example of the first part, right? There will be additional optional fields in this digital certificate, right? But you can see here, we come back to, we can map things to the standard, to the format, right? So it's, for example, here version is a version 3, right? Okay, serial numbers like this, signature, right? Algorithm identifier is actually SHA 256, right? Issuer is coming from US. Okay, the validity is actually valid from one day to another day, right? From July 15 this hour, and then to October 13th, right? And the subject here is a key for the Wikipedia, right? On of the web page under the DNS Wikipedia. So because actually I download this one is from Wikipedia, right? Okay, so the public key algorithm is ID this one, okay? And here is and the key here, okay? So the key is like that, right? And this public key is 256 bit, right? Because we are using the SHA 256. All right. Okay, so we go into the integrity design, right? Confidentiality we already covered. Integrity design to make sure that data is not tampered, right? Whether it's in the rest, data in rest, or data in transit. Okay, so we can use the hashing. All right, you can use hashing. We can use a referential integrity design, or maybe you can use a resource locking. Right, it's a physical protection. Okay, if you have a computer and you put into a cabinet and you use the lock, right, nobody can take out and then take out the hard driver to destroy, right, or to change. Okay, so how to check, how to use the hash, or how to use this one? Let us see here. Okay, for example, hashing, right? Hash is actually to condense, you know, we have a piece of data with a variable length, right? It can be, okay, and we want to condense this variable length of the data into a irreversible, collision-free, and fixed size output, right? Okay, and then so this output here we call as a message digest or hash value, right? So there existing a few, you know, hash algorithm here. MD5 is very popular, right, and common, right? HA1 and HA256, okay, right? And of course, so you see here, hash can also be used to protect the confidentiality as well, okay? So for example, password storage, right? So because the user can have long or short password, right? But you don't want to store the user password in plain text, okay? Then you can use hash to kind of encrypt, right, the user password and then save it into the database, okay? So the advantage of this one is that, you know, we can set the database, the length of the field in the database will be a fixed value, right? And then it will be totally independent with the length of the flexible length of the user password, because that one is a preference of every user, right? Okay, so it's on the right. It's actually the steps of the hashing algorithm. Okay, so of course, when for the checking the integrity, right? So the user send a document to user 2 along with the hash, right? So that means there are two things that a user have to send out, right? So if I want to send you one document, I attach that document in the email, and as well as I put a hash value, right, to verify. Okay, so on the other side, at the destination, the receiver will also do a hash, so also apply the hash algorithm on the document and then verify the outcome of the hash is matching with the hash value received or not. Okay, so that is how we check the integrity. If these two hash values are different, then of course the file is already tampered, has been tampered on the way to the destination. All right, so okay, preview dictionary attack here. Okay, so it's one of the attack. It can happen to the login page of your web application, right? So so because maybe the attacker knows that you use a username as admin, right? So they use a dictionary of all of the terms available in a dictionary, right? And then just like submitting repeatedly, you know, like in a loop to verify which one it will be, you know, will be successful. Okay. Okay, so hash. So when we use a hash, right, it can be used without a key or with a key, right? So with a key, we can have a sorted hash here. Okay, so we add some additional noise, additional things to the into the hash function to make sure that you know, the it will be harder to tamper, right? Okay, to guess. So for example, here we have to make sure that every user will not having the same hash value, even the content is the same. The input is will be the same, right? For example, let's say both user want to hash a value like tiger 123, right? But every user we use different zone value here. So end up we have these two different hash value, right? Because, you know, like we know that there are existing some of the common hash algorithm, right? MD5, and given the same given an input, we always have the same output, right? It will be, we call that is deterministic. All right, so whenever we run many times, we run the hash function on the one input, we will receive the same output. Okay, so that's why we need to add in the zone, you know, the zones for making sure that every user will have different values. All right, here's one more question. Okay, how are you creating the zone for the password, right? Whether you use the same zone for the on the password of on the user, and when and where and how you creating that, right? You can have a look. Right? So here's one of the example. Okay, here's one of the example. So we want to hash this this text, right, over graph, right? So we want to make this more complex and harder, right? So then the first step, then we add in the zone, and then we obtain this output. Okay, then we repeat again, adding this zone. Okay, so we can repeat looping this one. Okay, we loop 3 until like maybe like many times, like that we will have. We always have the same length of the hash, right? But the hash will change, the value will change. Okay, so it's becoming harder and harder. Right. Referential integrity is mostly used for the database. Okay, used for the database. Right. Mostly, right. So you learn about the database. I believe in other modules, right? To make sure that every record in one table have to link with other table. But because the problem is that your web application, you allow the customer to be, you know, like disable the account, to delete the record, right? You know, like delete the checkout, or you know, change the record, changing the order, right? So this is an example of the referential integrity. So the customer number 1 is linked to the record 1 and 2 in the order table, right? And then the order table, in the order table, we have only a few information, for example, order ID, order amount, and order date, right? But and then what are the details of those order? Then we have to link this one. Okay, so mostly this one, if you don't have the referential integrity, you will see that every table will be totally independent, right? And the problem is that if we have 2 account, 2 user, you know, maybe having the same first name and last name, just only have a different username and password, then you will have this problem here. Okay, so this one is without the referential integrity, right? So we look into the order, we don't know which order belong to which user. Okay, and even like for the order details here, we also do not know which the order detail of the first row belong to what order in the order table, right? Okay, and the biggest issue is like that when you delete, right? The problem is when you delete the customer, or you know, or the users delete their account, for example, right? So all of this function here, all of these records here become orphan, right? Okay, okay. So this, because of that, we need some kind of okay, you need some kind of referential integrity here, right? Okay, and you those project with your team, right? You have this, the delete function in the database. You have to think about this referential integrity. Okay, how do you handle when a user delete their account, you know, or deletes order, whatever? Okay, right. Resource locking, right? So just now I mentioned an example about a physical locking. Okay, but we do have the logical or programmable locking, right? So I, at the very first lecture, I taking the, you know, the example about a banking application, right? Because if you have a web application, you have a mobile app, right? Or, you know, then if both, you know, running at the same time, like doing some transfer, right? Okay, or maybe doing some withdraw money, right? So how do you update the account balance, right? So the resource locking here, that you need to bring in the mutex or like some global variable to lock, make sure that only one update at one time, right? Okay. Availability designs is actually most certify the availability requirements, okay, for a DDoS attack, or to avoid the single point of failures. All right. Okay. So if you don't have any redundancy, right? So then if something happen, if a failure happen, this single point of failure become a trouble, right? The whole system will not be available. Okay. So you should have some kind of redundancy, whether you will have replication of data, all right? Replication of data, or you will have multiple web front, multiple IP, right? Because of that, in the web application domain, you have a DNS, a load balancing, right? Okay. Right. So we replicate database and the software across multiple computer, and like that, if one of the computer fails, then the other computer will stand up and take over the role of primary. So here is how we deal with that with that scenario, right? So we have two nodes, right? Node 1 and node 2. One node is active and the other node is just a standby. Okay, so when node 1 when node 1 fails, then node 2 will stand up, will be active and take over the role of active primary node. All right, so there are two ways of for the scalabilities. Okay, we can have a vertical scalability, okay, meaning that we add more resources and to the existing node, right? So for example, if I have only one node, right, and then we face a lot of requests from a user, and that node cannot handle, then I will add some more RAM, add some more CPU, right? Okay, then it can have more resource to manage the user request. But so that is a vertical. Horizontal is actually adding another node. So instead of having one active node, you may have another active node here, right? Okay, another active node here, and then you should have a load balancing, right? Okay, so all the requests coming here, okay, and then is this load balancing can allocate the request to different active node. Okay, authentication designs. Yeah, so basic authentication is actually based on the log username and password, right? So that is what he knows, right? What the user knows, right? Or you can base on a biometric. Maybe it's too invasive, right? But the third approach is what he has, for example, access token or smartphone, right? And of course, all of you consider multi-factor authentication, okay, and a single cell, right? So 2FA, okay, here is 2FA here. A lot of you bring in 2FA for the application, right? Okay, role-based access control and user-based access control I mentioned in the previous lecture, right? And right now, role-based access control is predominantly a ways of authorization. Okay, so because it's more simple and it look more it look better, right? It's more efficient. Okay. It doesn't say that user-based access control should not be used, but it still can be used for a limited for some of the application with a limited number of user, right? And when you design and develop this one, right, you have to consider the special attention, have the special attention to the performance and the principle of separation of duty, right? And the list of the privilege, right? So we just mentioned about a list of the privilege, separation of duty, this principle in the first part of lecture today. Okay. right? You do have the admin super admin account in your web application. Think about how do you handle all of this one, okay? And that is going to be put into your second report, right? Implementation and yeah, the D2 report. Okay, all of this one you should have justification in the D2 report. Accountability design, right? So this one is for the auditing, right? And for tracing if there is some incident happen, right? I already mentioned with you that the log should have sufficient details to allow, you know, to enable the tracing, right? So those are the information we need to put in the logs, right? Who, what, where, and when, right? Apart from these four kind of information, who, what, when, and where, you should not add other information, because if you add more information, you may reveal some kind of sensitive information of the application. All right, okay. Right, so and when the logs here, right, saving in the database or saving in a different location, you should never log in a plain text form for the sensitive data, right? So you may have to bring in the encryption, you know, or anything else to something else to protect the privacy. Okay, right? So good logging design should satisfy all of this requirement. All right, so it should allow, you know, like should ease the developer to debug, do not contain any, you know, user information, because user information is a personal and privacy, right? And only store limited information. And you may bring in the log erase and rotation, right? Because we may not have the infinite storage space. Okay, right. I do have a few more slides on the on the secure or dry development. All right, so let us go quickly to that, maybe another 5 more minutes. All right, so the secure development cycle, is you are quite clear, right? We already mentioned about this. Requirement analysis, design, building, testing, deploy, and release, right? So that is the common process of the software development, right? But when we bring into the agility, then you have to bring in the agile sprint approach, you know, split the software into multiple components with, you know, less than 2 weeks or 1 month, for example, and bring in all of this, you know, carry out all of this step in that sprint, right? So every sprint you will have requirement analysis, design, build, test, and deploy, release. Okay, so like that, you will have better progress, you know, and you will have better, even when you have some bug or some issue, you can, you know, only look back to a respective sprint to fix, right? Each of the details of each of the design, each of the step we already have is here. Okay, so you can have a look at this slide. Okay, related to CIA AAA, right? We already mentioned a lot about this in previously. We repeat again some of the point very important, right? For example, related to the confidentiality, right? If you have this credential stored in the source code, make sure that you don't have this. Okay. How about a configuration file, right? Where do you store configuration file? How do you download a configuration file to the server? Okay, during the first launch, or how is it? So all of these questions, think about that during your implementation. Okay, we can discuss about this more during the lab hour. Okay, in terms of integrity design, should all the user okay, sharing a same credential or not, right? Of course, you already know the answer, right? We should not have the same credential for all of users, okay? All right. And whether the database credential have changed the password permission or not, okay? So we have to, these are the questions you allow or you do not allow. You should have some kind of justification in your report, okay? Right, availability design, authentication designs, authorization design. Okay, all of this one we just mentioned just now. Right, right. So this one is one example, right, where we store the password in the plain text. Right, so we should. This is a problem of the first C, right? Confidentiality. All right. So this one is look better, right? Because we use MD5, okay, to hash the password, right? This one could be more even better because we have a longer with a better algorithm for hashing, right? Okay, and this one even better, right? Because we have some zone for the hashing, right? You may have some more information about a user information table in your data scheme, okay? Additionally, right, for example, last login date time, you know, account create date, right? Whether it have a fair login count or not, number of the fair login, for example, okay? So all of this one, you know, when we have this kind of information, we can bring in the, you know, like the automate the alerting, right? Because for some example, some user having multiple fair login, we may raise up, okay? Right, password list is something quite new for some, right? It's only a recent year, okay? For example, Microsoft account now can go fully password list, right? Mac OS, WhatsApp is also password list, right? Okay, WhatsApp is actually the first one is in 2019 using a password list, right? So I actually use another channel to verify the user, right? Okay, so I don't know any of you in the group like using a password list for your system or not, but this one is really good mechanism for authentication. Okay, right, here are some example of the password list. Right, so I finished all of this lecture today. Okay, 6:05. Okay, so give me some time to answer a few questions on Slido, and then we can stop. All right, first question answer until Sunday, 23 hours, 59 minutes. Should 2FA CAPTCHA be included in the physical or logical? Okay, as I mentioned, if they are in a different physical location, it's not in your DigitalOcean, then you have to add in. Okay, then you have to add in because you have already a different trust boundary. All right. Okay. So there is one group, I remember one group discussed with me on the other day during the malware analysis lecture labs, right? So this one I have to emphasize, if the entity, the third party entity is in another physical location, it's not in the same virtual, you know, DigitalOcean, then it have to be in the physical, and it's also have to be in the logical architecture. But if those third party is in the, you know, like you deploy in the virtual, in the DigitalOcean, then it should not be appear in the physical architecture. All right. Okay, okay, I don't understand this comment. Transactional API, for example, you know, you do a checkout of your, you know, of the product, right? If you have an e-commerce, and then you do some transaction, you do some, you know, like purchase and do checkout, right? So that are the, and then those things you have to, you know, you have different API, different software component, right? So though we call that the transactional API. I'm sorry, can only until Sunday, because if you delay, if we extend until Tuesday, then the next report you will have a shorter time, right? Because anyway, on 10th of December, I have to submit the mark to the university, right? Okay. So the final date is always the same, right? You don't have, you cannot extend more. Okay, 2 more days, good enough. Should we present security requirement on our report as CCA? Okay, so until this moment, you still cannot differentiate between the functional security requirement and secure functional, right? Because the security requirement include 3 things, right? Security requirement includes secure functional requirement, functional security requirements, and non-functional security requirements. So all of these 3 things you have to present, right? Okay, CIA AAA is related to functional security requirement, right? So functional security requirement includes all kind of requirement related to CIA AAA. Hope it's clear for you. Security design, don't need to elaborate more details on how do you implement, because you will have that in your second deliverable D2. Mostly you will, you know, give a brief description about, you know, the security control. How do you use the security control that you use to mitigate the threats? That's all. How do you implement that? It will be in the next report, D2. All right. Brief introduction is good enough. For example, let's say you want to protect the confidentiality, then we bring in we employ the encryption algorithm. All right. But that is will be general, right? Then you have to map with your application. For example, on the login page, we for the user registration web page, I will have this kind of input, right? Username, login, the password, or birth date, for example. Then those information I will use in encryption, right? So it will be relevant to your application. Okay. Yes, you can shift. Okay, use case diagram have to be there in the report. Okay. I cannot imagine that. How come you have a very big use case diagram? It looks like your application is too complex. Okay. Right. So I regret that. What I suggest you that you have one big figure for the use case diagram, and after that you chop that figure into multiple small figure and add in the misuse case. I'm sorry, that is how we do right now. If we put the quicks until next week, can make the quick next week hard. So I got to move them. Okay, you should not demotivate like that. Okay, I will make it easy. Then like that, you will stay with me. Okay. Okay, include the mitigation in our misuse case optional. You want to add in is okay. If you don't want to add in, it's fine. Okay. What do you want to explain about misuse case? Every misuse case is only 1 or 2 sentences about a user story. But of course, if you want more details explanation, put into the appendix. So the whole report will be 30 pages, and then whatever you can put into the appendix, we don't need to, you can make a reference to the appendix, right? But we are not mandatory to read the appendix. No, you don't need to say AES or RSA at this moment. Okay, just need just only encryption is good enough. Okay, 30 page, and then additional 5 page in the appendix, well marked appendix. That's all for today.